We should see the record button, shouldn't we?
Go ahead.
Okay. Hello and welcome to day 2 of the Egeria Metadata Showcase. We're recording all of these 3 events that we're running. So yesterday's event, today's event, and the one we do tomorrow. And they'll be available on our YouTube channel. And at the end of the series, we'll send you an update with links to the video so you can watch them at your own leisure. So today, we've got 3 presentations. The first one you can see the details for already, metadata for the data-driven organization. That's followed by another presentation from SAS, which is focused on everything metadata. Then we're going to have another session from our first speaker, Mandy, and that will be looking at how to adopt and get involved with the Egeria team and adopt the Egeria framework. So while we're doing the presentations, we've got everyone on mute, and if you want to ask any questions or have any discussions with us, then you'll notice at the bottom of the window there is a Q&A button. Click on the Q&A and you can type your questions in there. We may answer some of them during the presentations, but we'll save them up for the presenters, because between the presentations we'll allow a little bit of time for Q&A. And also at the very end of the event, if we haven't run over time, we'll do some Q&A then as well. So there's the agenda, what we're going to cover today. So I'm going to let the 2 speakers that we've got today introduce themselves. Chris can go first, followed by Mandy, and she'll start her presentation then. So Chris, would you like to introduce yourself?
Yes. Hello, I'm Chris Replogle. I'm from SAS Institute in Cary, North Carolina. We do statistical and analytical software. I'm going to talk about what is metadata and where you should find your metadata in your organizations. I'll talk about that a little bit. And Mandy's going to bookend me before and after and talk a whole lot about metadata itself and how it drives your organization, and then the Egeria project. So please stay tuned. Mandy.
Thanks, Chris. So I take over. So I'm Mandy Chessell. I am a distinguished engineer at IBM, but also the project leader for Egeria. And I'm going to take you through some of the thinking that went on behind the project before we started. So let's start thinking about information governance and actually what happens in organizations. So let's get this to move. Yes. So for most organizations, they're large, and so they're broken down into silos because there's too much work to sort of coordinate in one go. So we break the work down, share it out, and you know, in a large organization, it's obviously more than 4 silos. It's obviously often arranged in a hierarchy, and then those silos buy their own applications, and within each application is the data that they're using, and this all works very well. But of course, in modern organizations, we want to use more than just the application data. We want to actually take the data out, combine it, and use it for analytics and reporting and all sorts of other things that are going on. And this is where the problems start. So data ends up having to be shared laterally across the organization. Typically, there's one big flow of data all the way to a data warehouse. And the data warehouse then takes all that data and creates this beautiful view of how the organization is operating. Now, the reality is most organizations are not sort of completely coherent in terms of how they operate. Each part of the organization has its own its own idiosyncrasies, and so there's a lot of munging of the data that goes on in front of the data warehouse to turn it into a single coherent model. In order to make that easier, there's a constant push back to the source systems to say, can you be a little bit more consistent? And that is perceived as governance stops innovation, because everything we change affects the data warehouse, and we're always being told that we must, we mustn't change, we mustn't be different, etc., etc. And that only works if basically what happens is that the people in the source systems feel they're doing all of the work to make data available, and the people running the warehouse or actually managing a data lake or whatever feel that they're getting all the value. And this really isn't fair, and the only way it works in an organization is if regulatory requirements force that type of operation. But if you really want a data-driven organization, data needs to flow between the silos and be equally available, with the value being distributed in all of the silos. So the data lake concept was step one in moving towards that much more fair approach. So the applications, rather than sort of exchanging data between each other, exchange with the data lake, and the data lake can then offer data-oriented services back to the team that own a particular system. So it could be quality, could be operational reporting, it could be different types of analysis, and maybe some analytical models running on their data. So there's value now going in both directions, and the more investment that that organization puts in their data, the more value they get back. Similarly with the people, you start to offer them more data-oriented services, and there's a consistency and a direct access between the people using the data lake and the data that's being offered. And you basically build an ecosystem. So more systems come in, more people use the data lake, and the value of the data increases. So that's a sort of an initial view on how you can start to create a more data-oriented environment. But as we discovered when we were working with ING on their data lake strategy, this is a really great approach, but that there is an awful lot of detail that's needed to actually make that environment work. And yesterday, Ferd talked about this data lake reference architecture that we created. It's been documented publicly, so if you're interested, you can follow the links. But what you see when you look at it are a great number of components and arrows, and all of these arrows are the services of the data lake required by the different users that it's supporting. Now, many of those services actually turn out to be metadata services. And so this is one of the reasons why the Data Lake project created a great interest in metadata and in a very broad range of metadata, and illustrated to ING that they needed to have a metadata approach that worked with many different types of technology rather than technology from a single vendor. Another thing that's going on in many organizations is to use a microservices architecture. And this from a data perspective is very similar to applications where the data is grouped into different into data models that support a small number of services. So data is being fragmented again in order to support the operational environment. But almost all of these systems also want to be able to do analytics, and we need to be able to sort of stick that data back together again. So the data lake is great for the history side, for building analytics, for sharing data. But it's not enough just to have metadata in the analytical area. We also need to have metadata in the operational area where microservices and applications are sitting, so that we can easily bring that data together, run the analytics, and then make good decisions as to where to deploy those analytics back into the operational environment. So the scope is growing, and this next picture starts to show how data needs to flow between the different environments. And you can start to see these are very different groups of users. The data science people working with typically read-only data that's being collected from multiple sources, bringing that together, creating a model that then needs to be deployed into the runtime environment, which may be the data lake itself, or it may be more of the operational environment. So we have to create metadata that works across the life cycle of many different teams. The other thing to think about is that there's not just one version of data in each application. There's the data that we've stored, which is the information collection. This is what's, say, on the disk. And then there may be an API, so the information service has a slightly different view. So information stored tends to be like a network of data. An information service is more of a hierarchy of payloads that are passed, sort of in and out on each API request. Then we have the processes. They may themselves gather data as they're operating. And then there's another view of data that's displayed to the end user. And yesterday, Ferd showed metadata influencing every single layer. So he showed 2 reporting environments that were using glossary information to give a consistent view to end users of what data meant. And then we had the metadata being used on the APIs to determine what data is available and also to discover where data is located. So metadata has to cover the operational and the historic and the analytical world, as well as being able to morph between the different views that are used up and down the stack within applications. So we end up with a picture that looks like this. There are actually multiple life cycles operating on this metadata. And the metadata is gluing many different perspectives and roles and activities together by creating that common knowledge base effectively between all the different teams. So here we've got a policy lifecycle. So these are all the governance teams. So this is privacy team, the IT infrastructure management team, security team, the team running the software development, the data governance team. So these are the people who set policies and measure how well the organization is operating. The development teams are the people who are making changes to the underlying systems that support the business. And then the operations teams are the people who are running the business and who are working with data and creating new value as they're working with that data. So many different types of people and many different types of metadata that needs to actually work together. So what does that metadata look like? So this picture here is trying to group the types of metadata that we believe we need. The first bit in the center at the bottom is the data assets. And the data assets are not just data sets, not just stores, databases, stores. They are data feeds, there's data messaging going between them. There are APIs, there are views over the data. So think of this data assets as really every type of collection or access to data that's used by the organization. That all runs on infrastructure, and that's shown in the yellow area, the base type systems and infrastructure. Generally, data is copied and merged and distributed. And so where the data came from is called the lineage. Metadata discovery is where there are automated analytical processes that are reading the data assets and discovering metadata around them. So not all metadata is fixed and defined by the developers when the data assets are created. There's other metadata such as statistical analysis of the content of the data that is also metadata, and that's what we mean by metadata discovery. Above the data assets are glossaries. So the glossaries provide business definitions for the meaning of the data that's flowing around the organization. Then we have the collaboration area. So this is things like comments and likes and ratings and other types of feedback that are linked to the different assets and the operations and the activities that are going on. And this becomes very important that we can share feedback from users using one tool. Maybe they're consuming a set of data, and the users of another tool that are actually owning and setting up and stewarding the data that the consumers are using. So this collaboration, this human to human exchange of knowledge and opinion is also a key part of the metadata story. I think we've got one more box left, which is the models and reference data. So this is the formal structures of data at a very concrete level, so the schema level, right the way up through to different levels of design model. And then reference data are lists of valid values effectively. So these are all the countries of the world, these are all the different courtesy titles, etc., etc. That's what we mean by reference data. So, oh, I missed one box, which is the governance. So this is the policies, the classifications, the terms and conditions that apply to the data as it's flowing around. And so this is the area that the governance teams create, and then that is then linked down onto everything else and controls the way the IT is operating. So that's the high level map. And yesterday we talked about the fact that there are over 400 different types, and they're all linked together. And it's this linking that is so valuable. I mean, so it's very useful to have a list of all your data sets, but to have that linked to glossaries so that you know what it means, and linked to different types of sort of profiling information and the lineage and things. So it's the sort of nuggets of information are important, but the linkage is critical too. And when we look at it, you can see it's very much like a graph. So this is at the bottom here, we've got some data. This is a sort of structural view of the data. So this is the schema. This could come from a database. This could be the database schema that explains how to map the data into a structured form. We could then link that to glossary terms. So now we're getting a business perspective on these definitions, and this helps to reduce the chance that somebody misinterprets what a value is, because data is not always easy to determine. You know, you have in a record for an employee, you have two addresses, their home address and their work location address. So unless you know the differences between them, they both look like addresses if you just analyze the data. So we need this extra metadata to be sure that we are interpreting the data correctly. Now we can get really fancy and start to put what we call ontological information. So information about how concepts are related to one another. And this means we can group data that's about something. So this is the data about an employee. And that helps us to identify what's personal data, and also how correlation could happen between different values across different data sets. And we can then take that at the business level and tag it. So here we're saying that the compensation plan, which is either the hourly pay rate or the annual salary, is sensitive. And now we know that everything that maps down onto all the different data sets that are mapped to these glossary terms, we know as sensitive data. And this becomes a very useful way of being able to identify where is the data of a particular type. That could be supporting the asset catalogue, where I just want to search and find my data. Or it could be used by a security engine that is looking at the classifications of the data and determining which data needs to be masked depending on the type of request that's pulling the data out of the database. So metadata is very valuable. There's lots of it, and it's coming, and it needs to be used across different tools. So I thought the next thing to do was to look at where is an example of really good metadata management. And I have to say that the digital photograph industry has done very, very well. So if you remember in the past when we were using films, we had to, our photos were printed, and then we had to write on the back what the photograph was about. And of course, not everybody did that. And so lots of us have got boxes of photographs that we can't quite remember who's in them and when it was taken and what was it about. But a digital camera today captures an awful lot of very useful information automatically. So here we've got the camera settings, the location, when it was taken, what time it was taken, etc. And all this helps us to identify where the photograph is from. And this is great for our own personal photographs, but it's also very important from analytics as well, because this data is captured automatically, it's reliable. And it means that we could take photographs from different cameras that are all for the same location and do some analysis on what's happening at that location over a period of time, because we can correlate with that metadata. And this is, of course, extremely valuable, and that's really where we're trying to get to. The other point is that this is taken on an Apple iPhone 6, it's taken a while ago, but I can use, say, an Adobe product, and when I upload my photographs, all of that metadata is available. So it doesn't matter who the vendor was that supplied the phone, supplied the camera. It can be used in many different applications because the metadata was captured, it's embedded, it's always available, and it's a standard format. This is really where we're trying to get to. Now, here's another example of a type of data that has metadata built into it, which is, it is a Word document, for example. And a lot of unstructured data does have metadata with it, but when you rely on a human to fill it out, so this is the metadata associated with this paper, and it doesn't take a genius to look and see that I wrote the paper, but I didn't update the metadata, and that is very, very normal. Most humans are really bad at any form of admin, particularly admin that requires them to search through a menu and update things. So this metadata, although is standardized and is able to flow with the data, it's almost, well, I would say it's less than useful because it's not automated. So this automation is absolutely key. So what about applications? Now, I've said before that in our modern digital organization, we need to be able to extract data from the applications and use it in lots of new contexts. But the problem with most application data is it is not like a digital photograph in that there is no metadata extracted. And I often think of the data as it's pulled from these applications. It's a bit like a tortoise without any, without its protective shell. You know, we really don't know. It's got none of the protection in terms of security, what it means. All of that information is now lost as we pull it out. So really what we're trying to do with metadata in that space is create that protective shell around it again. Not only the schema, the meaning and stuff like that, but also all the rules around associated with that data. And as I'm describing that, you can see, well, that's actually starts to correspond with the layout of metadata that I talked about earlier. And again, this automation is coming up in terms of ensuring that the metadata is accurate. And many people have recognized that this is important. And so there are a huge number of metadata repository products that allow you to capture this type of information about your application data. They have different levels of automation in terms of how much they can extract automatically and how much requires people to do the updating. But if you certainly in the open source space, there are new metadata repositories turning up almost every month. So this is a well-recognized approach. The problem for most organizations is that there's too much of a good thing in that every product, every tool suite they buy has its own metadata repository with its own proprietary format. So we're not now able to take information from an application that's been loaded by one metadata repository tool and use it in another. So we haven't got that flexibility in the same way as we do with digital photos. So this was the original list of the things that we wanted to do for Egeria, is this automation and the standardization and the ability to have the metadata always available, but also with no particular vendor in charge. And so that it starts to become an integral part of everybody's working operation. Now, in order for no vendor to be in charge, this needs to be a peer-to-peer environment. It needs to have very little centralized infrastructure, so that an organization that is highly decentralized, federated organization can still operate in this environment, because typically funding still comes down the silos, and so central investment in technology is actually hard to do. So we want each part of the business to be able to choose their own tools, but then we will bring those together through Egeria. Pictures like this make it look like it's all in one place, but of course modern environments are cloud oriented, and we have stuff right out on the edge in IoT systems. We have stuff on premises. We have stuff not only in one cloud, but in lots of different clouds. So Egeria not only has to handle that peer-to-peer-ness, but it has to work across a very wide range of environments to create that integration. So here we have a set of integrated systems, but we also have to be able to share metadata with data as we move between different businesses, because many organizations today have digital business partners, and so metadata needs to flow with the data. So just like the digital photograph went from an Apple phone to an Adobe photo tool, we need data from the hospital to come to the pharmaceutical company with the attachments that say this is where the sensitive data is, these are the terms and conditions for this particular data, and make sure that that is retrieved and respected as it comes into the organization. We do this through this idea of a cohort. So the cohort is the peer-to-peer sharing of metadata between different systems. And there are different patterns and integration mechanisms that Egeria provides to minimize the cost to any vendor in terms of bringing this in. So here, any metadata, that's added, that say published by the system of record, is then available to the Chief Data Officer's tools and the data lake tools. This process, this cohort structure is dynamically managed. As each new tool joins the cohort, then metadata starts to be shared. And it's replicated as a way of improving performance. But the real power is that each tool is able to issue federated queries to all the others. So you've got real-time access to the latest metadata across the organization. As organizations get bigger, you might have multiple cohorts. So here the Chief Data Officer is connected to everything, but you might have two divisions of an organization that really don't care what the other's doing. And so they can operate in their own cohort, minimizing the scope of data that each team sees. What's going on behind the scenes is that we are building this huge distributed virtual graph of all the different types of metadata. So here we've got two repositories with two pieces of metadata in them. One is a database column, and the other is a glossary term. So it's a definition of the meaning of something. And we want to create a link to them, but they've been created by two different tools. And we have a number of choices. We can, whoops, went the wrong way. We can copy the glossary term into the first server and link it. This copy is managed by Egeria and is managed as a read-only copy. So any changes to the glossary term are automatically updated and reflected in both servers. So that's one way of doing it, but it might be that server one doesn't support glossary terms, in which case we can use an Egeria native server to take the metadata from both servers and create the relationship in our server as well. And, and any query from any of these servers will actually return all three pieces. It doesn't actually matter however we've done it. So a little bit back to the wide range of different people who care about metadata and who need it to become needed in a data-driven organization. We use a company called Coco Pharmaceuticals. It's completely fictitious, but all of the characters in here have actually are actually based on real people in real situations across many of the organizations that I've worked with over the last 5 or so years. So they are very real environments. And when we look at each of these users, we realize that they each have very different requirements, even though everything that they need is all linked together. And the activity of one triggers events in the other. So it's very event driven, but it's also very specialized for each of the roles. So we divide our services into 2 layers. One of the repository services that's managing that cohort, and then specialist interfaces above for particular types of tools. And they sit around that core model, each supporting a different tool. And then around that, we add servers that actively exchange metadata between different types of tools, depending on their capability. So relational databases typically are quite passive, so we would poll them to check their schemas aren't changing. Something like Apache Cassandra sends out an event every time a schema changes, so we can listen to that and bring it into the ecosystem. And of course, we offer APIs to allow applications or individual tools to directly interact with our server. So, in summary, what you start to see in the Egeria environment is that huge range of metadata. Think of it as that big virtual graph. Different parts of the graph are stored in different metadata servers. And then the governance servers that sit around the outside provide active integration with different types of tools, creating that integrated environment for the data-driven organization. So, questions?
We have a few questions, Mandy, actually.
Okay.
So which was really good. So the first one, I'm not going through quite in the right order, sorry. Is there a place for external vocabularies in Egeria, such as schema.org?
Yes, we can load them in and we can show where they came from. So we can provide proper provenance back to the original source and also bring them in and make use of them.
And I think, and this is sort of referring to things like the SIM model, is it? And
the SIM model or schema.org as well. So these models are all exported in standard formats like JSON LD. We can read that and then translate it into open metadata. And so everything we do is we take from the standards and we bring them into Egeria. And the reason we don't use the standards directly is for most of them, they cover a subset of what we need to cover. So we respect and make use of the standards, but our internal model is like a big patchwork quilt where we've stitched the content from many different standards together.
Okay, that's good. And as David commented in the chat, he's running a, so we've got some themes within Egeria. You know, for example, there's a lineage theme that we talked about yesterday, and schema and glossaries and being able to import them is one of the themes that David's running. So if you're interested in getting involved in any of these, you know, please look on our Slack channel. Or go to, you know, the GitHub page to find out more information, as anyone's able to join these. We had another question, and you'll know about this because you used to be a maintainer for this, Mandy. What is the status of the Egeria to Apache Atlas integration? Is that production ready and when?
Okay, so what we have at the moment is the ability for an Atlas repository to share metadata with the rest of the open metadata ecosystem. So it's, you know, it can be, join a cohort and share metadata. What it's not able to do is to receive metadata from the open metadata ecosystem. And that's because it's unable to support that read-only aspect of our reference copies. So when we bring metadata that's owned by a different repository into Atlas, Atlas needs to respect that it's a read-only copy. And so it's a small change that's required to Atlas to enable that piece. But until that's in place, we support that. We support the sharing, but rather than the storing. And that's an important part of the Egeria protocols because there are different profiles that particular technologies can support. And we enable it to connect in, even if it's got very simple functions, and we fill the gaps effectively for that repository so that it can be a full part of the cohort.
Mm-hmm. And if someone has got a repository, then we have a conformance suite that they can test to sort of say how compliant that is, whether it can deal with bi-directional communication or just one way or whatever.
Exactly.
So do you want, actually, one other question that was quite interesting. I know when I started working with the Egeria team, Egeria is quite different from a standard metadata repository because it's not focused on bringing all the metadata and sort of controlling it. So do you want to sort of elaborate a bit more about that, because it is sort of more of a network?
It is a peer-to-peer process. So you could actually operate it with no Egeria metadata repositories installed in the cohort, as long as the other repositories have enough function to support what your users need. Then you know, each vendor product just connects onto the cohort, and the cohort operates. So Egeria itself is not a big central repository. It is a metadata integration platform. That's its. You know, if you wanted a single line, what does it do? It exchanges and federates metadata from multiple repositories without requiring a single centralized metadata store.
Okay, fantastic. I don't think we've had any more questions, so thank you very much. And so in keeping on time and everything, Chris, if we hand over to you now.
Yeah, let me hit the stop share button. Okay.
Chris, I think you might be on mute.
Just a second,
Oh, that's it.
getting it shared up. All right, can you see my screen now?
Not yet. Oh, here we go. You can see your screen now. That's perfect.
Okay. All right. Well, let's see. I'm going to talk about metadata, but a little bit higher level, more abstract than Mandy. Not necessarily Egeria specific, but what you should see in Egeria and what we're talking about for metadata. So a little bit about me. We talked about it earlier. Chris Replogle, software developer and R&D for SAS Institute. I'm going to talk about metadata today. Basically, it's more about what is metadata. You know, what's metadata telling you? What are you discovering? What are you trying to figure out with metadata, and where you're going with it? And a little bit about the semantics that drive that word metadata. The questions we ask about it, what we're going to do. I've got some nice abbreviations there for the what, when, where, how, which, why, those kind of things. So I'm going to break that down a little bit. So what is data? Well, basically, you know, most people know what data is. It's some kind of information or knowledge somewhere coded in some form that we can process or deal with. And that's a generic representation, but that's basically what it is. It could be structured, it could be unstructured, it could be streaming through. There's many different ways we consume the data that we have. So taking that far, what is meta? Well, meta is more about that prefix that says digging into itself. So like metaphysical is where physical, you know, understands physical. Metadata is where data is understanding data. So it's information about your information kind of thing. So in typical database form, you see that as metadata as being information about the tables that describe that information, or about the columns that make up that table. So it's about the objects and the relationships and how they connect together within that. So basically it's describing that information. So we take that out a little bit more and get a summary for it. Metadata is really information about information, or getting knowledge about our knowledge. And that's key for what we're trying to find. We're trying to find information, we're trying to share that information, trying to get what we need to do to solve the problems we have at hand. So kind of what is a data element? In the metadata kind of generic terms, it's just a single unit of data. It's an atomic unit. It's precise meaning or precise semantics, right? Like, you know, a piece of data is like, I don't know, my name, Chris. It means nothing by itself. It means it has to have context. Is it got a first name? Is my last name? Those kind of things. So you need that metadata to help describe what it is and where it goes. So if we start investigating our data, we start looking at the questions we want to ask about our data. The who, the what, the when, the where, the which, the why, the how, right? We dig into that data. We want to know about that piece of information or knowledge. The who, these are the kind of things we want to know. You know, who created this piece of information? Who modified it last? Who's been reading that information? Who deleted it, or was part of that information deleted, and when was it? You know, the concern, who should I notify when I change something or update information around that? And then secure, who manages and secures that data? Who should I tell or notify if somebody else needs access to that data? That kind of thing. What? So we move on to what describes the elements that it represents. What is that data? It's got some kind of identity, some kind of label or name that describes it. A full description, a nice descriptive information about that data. Whether that's, you know, the data itself is just a term that gives you information, or it's the actual column itself. It still needs descriptive information to describe what it is and what it does. Some kind of type classification or data typing that says what kind of thing this is. And then attributes or traits or facets of that data that give us kind of more complete information about that. And then, of course, the more important thing is the relationship to other data elements, or even data that makes up that graph of that object or metadata around it. For example, a table has multiple columns. So there's a relationship between the table and the columns that's contained. But there may be other relationships that says, hey, this is also a column used in an index or in a key. You know, those kind of things give you that kind of understanding of the context of where it is, or the what of the data. When? Well, we need to know time. We apply time here. It's like, when was it created? When was it modified? When was it read? When is a piece of data deleted, or pieces of that data are deleted, right? If I have a list of employees, when was somebody changed? And when's the last removal of an employee? Those kind of things. We want to know the history. We want to know progression over time, how things have changed and where they went. The where, the location of the data. Where is it contained or stored at? Where did it originate from? What's its cyber location? Where is it stored at right now? And what's its geolocation? Is that data replicated in multiple locales and multiple geolocations, or is it stored somewhere specific, whether it's a physical asset or a cyber or digital asset, either way. Which, we get back to time again. You know, maybe I had multiple models that I use for analytics, and those models, certain ones are only effective at certain dates. So what date range was this piece of data effective for my operational consumption? Those kind of things matter. We need to know which one was the right one that gave us the right result at this time we used it. And then why? We need to know what was the purpose of that piece of data. Why do we have it? What did we do with it? Who did what to the data? The history. Why were there changes to the data? Why was it even created? And what's the relevance of the data going forward? Why is it pertinent to me? Why should I care? And then how. How describes the processes and actions and the things that act upon the data. The lineage or the provenance of data. How did it come into existence? Where did it come from? How was it gathered or captured? And then what is it related to, and how does it come forward, right? So if I think about change analysis, if I change the name of a column, what does that affect downstream, right? So I need to understand the lineage of that column to where it gets into reports or into presentations, those kind of things. And then I also need to know audit records. How has the data changed over time, and who changed that data over time? So if I take all those questions and kind of spin them around and turn that into a bigger picture, I can put it together something like this. where I have my who, what, when, where, which, why, and those kind of questions I ask, but I start looking at all that metadata that it creates out here and related to it, right? That what, when I talk about associated metadata, all the things related to this thing, the how, those lineage and audit records, the why, and those kind of things. So I put all that together, I get a much bigger picture of what data is. And that's my quick 30,000 feet explanation of what is metadata. It's all those things. Now, here where I say data, that could be any information or anything I can describe, whether it's structured, unstructured, or anything. So that gets us kind of into that picture of data. So I'm going to ask for questions on this. The references for what I have, most of this, everything in this came from Wikipedia entries for metadata, data element, metadata registry. Those are all open and available to you. Any questions about what metadata is?
Not got any questions, Chris, so much. I was going to ask you though, if anyone wants got any questions, if they want to sort of type them in now, that would be great. But one of the things that you mentioned was changes to the metadata. I don't know if you want to talk about, you know, the way Egeria sort of deals with that, because we sort of let people know.
Yeah, I was planning heading down that direction. It was more related to the lineage. When you talk about the lineage and how things have changed, Egeria has a lineage service. We saw talk about that in a little bit of demo about that yesterday. That service can accumulate metadata as it changes over time. You look at Egeria and you can see what the current landscape of the metadata is, but I could theoretically query the lineage service and find out what metadata is over time also, to see how something's changed, the metadata for it's changed, and how the relationships have changed over time. So that gives me a more of a time machine kind of query and seeing things as they change over time.
So I mean, I think one of the things that's quite interesting is the fact that Egeria's got sort of Kafka based in there, so people can actually subscribe to if changes have happened in data, you know, or the metadata that they're consuming. So which is quite an important thing. And I know when I've talked to people, they've been quite interested in this, you know, because dealing with change within an organization can be exceptionally complex. And when there is so much data, you don't always know who all the individuals are that are potentially using and utilizing that. So that alerting is quite an interesting bit.
Right. Now, I have a little bit more I was going to add, but
okay.
I figured since we're talking about metadata and data, basically we kind of get in why do we need governance and our data usage, right? So we don't really need to worry about governance and stuff, because if you only have one person consuming the data, it's not shared. But as soon as you share data and it's accessible by one or more persons or processes, then you need to worry about how you're going to govern that data and those kind of things. Where Egeria can do a really good thing of adding in that information about tracking where that metadata is, how it's shared, how it's shown, where it's connected to. So if I take that through and talk about why do we share our data? Well, we want to make data available to others. We want to get the correct data where it's needed. We want to collaborate. We want to ensure we have quality data where it is. And we want to reduce our duplication, right? But data sharing implies the need for governance, right? It's informative to the organization. It makes it available, but we need to know kind of how we're going to manage that thing. And then, so we need to manage how we share data, right? We have some kind of data use agreement. So we kind of have a contract for how we want to exchange or transfer that information. Because typically it's not public information we're trying to share, either between two organizations, between two people, between a person and an organization, or even two business entities themselves separately. So we need to understand how we're going to do that. The data use agreement typically talks about the data lifecycle, the retention, the archiving, how you destruct or transfer data offline, compliance standards or regulations that govern the data and how that's related to the data, and the data protection, management, and security settings. Those are all pieces of metadata that should go with our data. Those are all pieces of connected information that we want, that we put around those things. For example, data protection and management, I may want some kind of data policy, and a policy I apply and run with the data. Egeria has connectors for connecting to policy systems and integration of that. If I'm enforcing these things, I need to know what those policies are. And those policies kind of describe and define how the data is going to be secured, consumed, validated, and even what thresholds are there for the data. By thresholds, I mean, you know, it should know what people and what groups it's shared to. If it's shared to groups other than that, that's probably a violation. That's a threshold that's been overcome. It also should understand what the data regulations are within that. The rules and processes, those are just things that validate that we're compliant with whatever those standards are. And then the stewards, as Mandy talked about earlier, is the team that governs that data. The persons who ensure that the standards and compliance are being run. So if I take that, we kind of understand that we're getting a privilege to use data, right? It's not just a granted free thing, right? We have to track where we consume data, where we produce data from either internal or external sources. And we have to be respectful and transparent in how we do those things. We need to know the sensitivity of the data and relate that back through the business terms and those kind of things for how, you know, relative or relevant information is, and then how secure it should be also. And we know what regulations and things are related to this data that we have. And to do that, I may need multiple tools, and to relate and connect them together, I need a tool such as Egeria to do that. That technology there allows me to connect those disparate sources and management tools for these things. So what that basically builds is the governance landscape, right? We need to know how the data is onboarded within your organization, what the life cycle of the data is, its lineage, the data provenance. We need all those pieces put together to have good governance in our systems. We need to know who can and should have access to the data, the security around it, the policies, the rules, the decisions that are even made based on that data. And we need to have some kind of rules, alerts, and thresholds to be able to build dashboards or information centers to know what the status of our governance is and where we're at in our landscape of our governance. So what I'm kind of saying is, now we know what metadata is, we need to discover those things. So discover your data, figure out what your metadata is, gain more insight in what information and where it is and how it's relevant to your organization. If you want to learn more, I recommend going and looking at the opengovernance.odpi.org. That leads you into Egeria's guidance on governance and digital services, and a lot of things connected to how Egeria and ODPI relate into governance of data and metadata. And that's it for me.
Okay, we've got a question for you, Chris, as well. So are there any SaaS products that are currently integrated with any of the Egeria modules?
Currently, no. Those are currently in development. We are currently actively working hard trying to get to integrating in with our stack. Those things, we really want to get integration on our analytical models, machine learning models, either through the open model management that we have or through our model manager products. Either way, we want to try to get those integrated in as soon as we can. Sometime this year, hopefully, we'll have Egeria integration.
Do you want to sort of, I don't know, talk any more about what that might be like, or how it might help with the, you know, what sort of benefits will that bring?
What that will bring is we'll do discovery of SaaS assets, so data sets in the SaaS world, and do discovery of those and how they integrate in. We'll also be aware of what data is getting consumed by models and analytical processes, and then what data is produced by those analytical models and processes, and where that's consumed downstream in BI reporting and other tools. Without Egeria integration, I don't have that direct connection. I'm a local vendor, I'm stuck within my own vendor space. But with Egeria integration, I can see those connections of SaaS tools together with IGC from IBM, Atlas from Apache, and other tools and other organizations. So, and it gives you a live metadata picture by doing those connections with a cohort versus traditional where you do batch export and import, and it's never up to date, and it's never in sync. So Egeria is the next generation, and SaaS plans to integrate well with them.
Mm-hmm. Yeah, well, one of the key contributors as well. So I had one sort of question, which is, you know, talking about metadata, there's almost a limitless supply of types of metadata that you can add and create. And I know you're talking about security and things. And one of the other webinar series that we've got actually on the YouTube is one that we did with Palisade, which is another open source capability, which does access and policy management. And we used contextual based information about, driven by metadata, to set the access rights for people when they were putting requests into, access data. So, if you're doing multiple types of queries, say, for example, one query is to do some salary analysis, then your data scientists, you don't want to be sharing with them any personal details about the people if they're looking at salaries. That data scientist then maybe later that afternoon does some more analysis, which is around identifying staff who might be applicable for a free health check because they've been at the organisation for over a period of time. So they want to email those staff to tell them they can get a free health checkup as a special offer. So in that case, they'll need to see some personal details and email addresses. So what we did in that particular webinar series, we used the metadata that we had to set context for each sort of activity that data scientists were running to sort of drive that context. And I'm sure there's lots of other metadata types that you can think of. It's almost a limitless number. Some automatically created, as Mandy was explaining, and some created by data stewards and by individual users rating data. Wow. Okay. I'm just looking to see if we've got any other questions. No other questions. If anyone wants to sort of add anything in the Q&A. What we can do, if we add something else in the Q&A, we can come back because Mandy and Chris will be available at the end if you want to ask any other questions or any more sort of generic questions. But, fantastic that SAS are adopting Egeria, and that's going in. And there should be some fantastic things coming out of that later in the year. So Mandy, if we hand back to you, you were going to talk a little bit now about adopting the Egeria framework, sort of becoming more involved.
Okay. Just looking to see if I can share the whole screen. Okay, so hopefully I'm going to... Can you see the charts okay?
Looks good.
Thank you. Thank you. Okay, so this last section is just talking a little bit about bringing the technology we've been talking about into your own environment. So how do you deploy Egeria into your environment? So there are a number of ways of looking at the technology we've been building. At the base is a set of developer libraries that you can use to build your own integration. So you can basically take our support for the cohort and create connectors that allow different types of tools, particularly if you've got homegrown tools, and bring that all together. So that's what we call the developers toolkit. Then we have the integration platform, which is the pre-built integration we have with different types of technology. So there was a question earlier on about our integration with the Apache Atlas, and that would be an example of a connector that sits in the integration platform. And then finally, we have the top-level governance solutions. And many of the concepts and demos that we had yesterday are sitting in that layer. So, the historical lineage, the support for security for data scientists and things like that. So they sit on top. And you can either look at this as a pyramid stacking up, and there's more code at the bottom than there is at the top, or as a roadmap going into the distance, because we build on our toolkit to build the layers above. The toolkit is the most mature, and the other pieces are less mature because they, as I say, they require the developer toolkit to get going. But if I now fill out the boxes, what you start to see here is at the base, in the I'll put developer platform here, same thing, are the base frameworks. Right at the bottom here are a set of base frameworks, and these are the places where you plug your adapter effectively, or connector into. So the Open Connector framework defines the APIs for the lifecycle of an individual connector, whether that's mapping between Egeria and Apache Atlas, or Egeria and a relational database, or Egeria and a data science tool. All that mapping is done with connectors. The discovery framework has specialized connectors for doing automated metadata discovery. So they have additional support for creating and documenting all the insights that they're gathering about a particular asset and storing that in the metadata repository. And then the governance action framework is all about the governance and stewardship actions and the way defining and attaching the right policies and rules to specific elements. And finally, the audit log is all about providing first failure data capture to the operators and administrators that are running Egeria. So the aim is to provide meaningful messages with actions to take when certain failures happen within the Egeria environment. So that's the frameworks, the sort of very base plugin area. Again, they can all be used independently of Egeria or with the rest of everything. Above that is the platform. So the OMAG server platform is where we host all those connectors that we've talked about. And so there's a chassis which includes the web application to support REST APIs. The admin services is how we control what's available and define the connectors that are to run. Platform services allow us to see what services are active in what we call servers that sit on top of the server platform. Multi-tenancy allows us to run multiple different servers on a same platform. So we can support multiple instances of the same type of server or a different servers, each performing a different function in your organization. So if you're a small organization, you probably have one platform with one of each type of server running. Or if you're a large company or you're operating a cloud service, you may have a platform or multiple platforms and the same server is deployed across those platforms, giving you high availability and scalability for your deployment. And finally, metadata security is absolutely critical for us because when the tools were all in their own silos, you could control which users saw which metadata. As we bring it together, we need to create a more virtual scoping of metadata to make sure that information about very sensitive data is only available to specific people. So we can secure on the platform, on the server, on a specific service, on a particular element in the database, on a particular type of asset, a particular type of connection. So the metadata security in Egeria is very comprehensive. Above that, we've got all the different services. So the repository services manage the cohort. Access services provide all those different APIs, specialist APIs for different types of tools. The governance services are managing that integration, that exchange of metadata with different types of tools. So they sit in the governance servers. And then the view services provide REST APIs for front-end applications. So you might like our UIs, you might not, but providing these view services means that a vendor can integrate our function into their tools with very little effort so that they can provide their own look and feel on top of our services. And then the open metadata types we've talked about, these 400 plus types that define our language for talking about metadata. That's the developer platform. As I say, you can use them independently together to create your deployment environment. On top of that, we are interested in supporting organizations that maybe don't have a lot of developers. And so we're building integrations to third-party products, typically open source products because we're an open source organization, and also utilities for reading different types of standard formats. And we talked a little bit about JSON LD earlier on as an example. And then we've got UIs for people who are running Egeria to be able to see what's going on. So configuring and operating the platforms and the servers sitting on top of it. The Type Explorer allows you to view the types defined within a particular server or cohort. Repository Explorer allows you to step through that huge graph, that virtual graph of metadata that is being managed by Egeria. And the Cohort Manager allows you to see the health of the cohort. That's the integration platform, so I say for the technical team running Egeria. And then above that, the governance solutions are really starting to provide that enterprise-wide capability that the business teams will care about with Egeria. So we've got managing assets, handling the fact that we get duplicate metadata because we've got lots of tools potentially pulling the same metadata. And as we bring it together, we need to identify these duplicates. Managing the availability of data to data scientists, and this is the piece that Moy was talking about earlier on. The historical lineage, the ING team showed that yesterday. Subject area management is all about building definitions of different types of domains of data. And the governance program is about creating the policies and working between the different governance domains to create that coherent view of how the organization should operate. So these are the different layers we have. And when we deploy Egeria, effectively, I talked about it being a very distributed environment. So you imagine you've got different data centers or different organizations that run their own machines. Each of those environments is represented by the green cloud. You then put one of our platforms into each of these environments, and that will run, or one or more, let's say, and then they will run the servers, and each server supports a particular type of tool. It's the easiest way to think of it. So when you're thinking about planning for Egeria, you think about, well, what tools do I want to integrate? Then look at the type of servers, and that determines what you put on your platforms. And then Egeria itself, depending on the type of server, knows how to organize the environment and create the exchange. So you don't have to think about that. That's done for you. Different types of, see, where are we now? So I talked about the platform being very versatile. So we have to cover a huge range of operating environments. So you could have a small environment where you run lots of different servers on the same platform. You might have a Raspberry Pis deployed throughout a factory or whatever. And so you can put server platforms small enough to run on a Raspberry Pi. And maybe you only have one server that's managing the sensors that are sitting within that deployed environment. Or you might have a very large scale cloud deployment where you want to offer a high availability. And so the same servers are deployed across multiple platforms so that the platforms can do rolling updates, or if one fails, then the service is still there. So a lot of flexibility in the way you can deploy it. And I talked about different types of servers. So this picture shows you the dark orange are the different types of servers, and then they're organized into a hierarchy, which determines how they're configured and how they're operated and where they sit in our architecture. So this tells us how the servers will communicate with one another as they go forward. And so the cohort member here, these are the servers that connect in that cohort, that inner ring of sharing of metadata. The governance servers, these are all the different types of governance servers here. They're integrating and managing various higher level types of governance. They sit outside of the cohort members. So they connect to a cohort member, and so they're like the next layer out. And then the view servers sit out even further, and they're supporting the UIs on the outer edge. And if we connect that all together, here you can see in the center here are the cohorts. Then we've got the governance servers, the next layer out, talking to external technology. And finally, the view servers supporting our UIs. And this is basically the Lego bricks that we have when we're putting together an integration across an enterprise. And so if we take this picture again, which I showed right at the beginning of the session, these are the cohort members, the metadata servers, the repository proxies sitting there. And then they're connected. These here are the data platform discovery server, the stewardship server, virtualizer, security sync. These are the governance servers that sit on the outside. And then the tools are hanging off the outer layer here. That's how that environment is set together. So where are we? Remember this picture, the layer cake and the three things? Because one is built on the other, if you look at our status, you see that the developer platform is looking pretty green. There's an awful lot of function there. It's reliable. It's been running in production in IBM's cloud for a long time, for well over a year. And then as you get higher, you can start to see that there's work going on. So the green means it's either at least at the tech preview level. The orange means that there's working function in our master, and red means that there's code there, but you know, you take your chances as to whether it's working. And we try and publish the code as we're in small pieces continuously, so that people can give us feedback on our APIs and various other functions as we're developing it, rather than sort of deliver complete function that's perfect, that then is much, much harder to change. So if you want to follow, if there's an area of interest, if area of code that you're very interested in, and you want to be actively involved in the design discussions or even some of the implementation, then you are very welcome to join our group. Let's keep an eye on the time here. Now, the newest things, if you've been following Egeria, is that we have a new UI called the Repository Explorer, and which is nickname is Rex, and that complements the Type Explorer that we had before. We've got this duplicate asset detection. So there's a new governance server called the Discovery Server that's supporting this duplicate asset detection. And then the audit log framework is the this first failure data capture framework for managing logging and messages for exceptions. This is just some screen captures from the new Repository Explorer. It's a beautiful piece of work, and we have this in tech preview. So if you're interested in giving it a go, you can start with a single node and then explore out, create a graph view, create a report from that, undo it, go down a different direction, etc. So there's a lot of flexibility in this Explorer. So what are we doing on time? That's right, we've got a little bit of time left. I wanted to take you through all the other resources that we have with Egeria. So I'm going to come out of PowerPoint, and this is our website. Is that showing okay? Is that readable? It's rather big. So this is our homepage, and you can see the picture that I showed you earlier on. But here are many of the links that you will need to get involved with Egeria. So we have a whole series of tutorials that run in a pre-built Kubernetes environment using Jupyter notebooks, and I'll show you what they look like in a minute, that allows you to explore many of the features of Egeria. There are also different guides that will help you think through how you're going to deploy. So you see these pictures that I've been taking you through. There's the admin guide that will take you through all the different types of servers, and you can just literally follow the type of server, and it will take you through all the configuration that's required. Let's go back to the front. Developer guide takes you through how to set up, oops, hold on the way. Takes you through, let's see, yeah, it takes you through how the connectors work and the logic. So this is a guide to help you build your own connectors for Egeria, and then links to all the different examples that we have in our implementation. The diagnostic guide is pretty empty at the moment. Then we have the conformance suite. So this is when you're working on your own connector for a repository, you can use this test tool and it will test your implementation and then give you feedback on how well it's working and what you need to do to fix it. So those are our guides. Then there's a link to the different types. The terminology we use, our glossary. This is the pictures that I showed you a minute ago and the status, and you can click down and link to specific functions and see the status it's in, as well as the documentation related to it. So we have an awful lot of information just on the website. I just need to move the screen because these are our labs. Each lab, there's a sort of read me first when you set up the environment, explaining how to run them, and then all the different characters we have and the different labs that are available. And they will allow you to step through quite a complex environment that's been set up and work with the APIs, with all the concepts, and make changes and experiment with the way that the way that Egeria operates. So it's for quite technical people because it's issuing requests, but it will give you a very grounded view of the metadata of the Egeria function. Chris talked about the guidance on governance. That's this page here. And it will take you through different aspects of governance, and also our cocoa pharmaceuticals, tutorials and scenarios. And the aim, this is always work in progress, but the aim is that you can start with the data governance perspective and then work your way down through to the samples in Egeria, so you can move everything. You basically can go from the theory down through to the practice with this site. And what else? And I think I will finally say with our GitHub repository, this is where all the action is. As you can see, we're a very active community. We do a new release every month. And so that chart that I showed you with the status is constantly changing. So please check back with us regularly and see how we're doing. Okay, I've finished.
Okay, you've got quite a lot of questions now,
Oh,
Mandy.
gosh. Let me stop. Well, actually, I'll stay sharing in case there's anything I can share.
And actually, I know Nigel Jones, who's one of the maintainers on the call, and I think the last question we had in Q&A might actually be relevant for Nigel. So Nigel, if you could answer in the Zoom chat window, that would be great. We had a question, where can I find documentation about the Java wrapper for using Egeria Maven dependency? So I know Maven's one of the tools we use, but. So Nigel, if I leave that one for you, you can probably find the question as an open question in the Q&A. And then, hang on a second, I'll just go over to the questions that we had. Which is the first one? That's that one. Talked about. So we talked about cloud deployment. Which cloud vendors are integrating or looking at integrating with Egeria?
At the moment, only the IBM Cloud has Egeria in its Cloud Pak for Data products.
Yeah, and looking at other cloud packs, but Egeria will run on any cloud.
Yeah, I mean, the thing is, it does run in Kubernetes, so every cloud vendor supports that. So you can host Egeria yourself in that Kubernetes service.
Okay, and then the next question was so in the notebooks, so when is the lineage lesson in the Python notebook? When will that be included in an Egeria release?
I'm not sure. I mean, one of the things with an open source environment is that it's very, basically we release what's available each time. We have a rough idea of when we think things will be ready. But the way an open source community works is if somebody puts something up, even if they think it's ready, if the rest of the community says, well, actually, we're not happy with it, then the code is reworked. So stuff is generally released once everyone thinks it's ready. So we're always a little bit hazy on dates. We publish our release schedule, which is a very optimistic, assuming nothing happens, type schedule, and if things aren't ready, we just shift it out through releases. So the work is very close. That there is a notebook. It's just the people involved with it are still they still want to do more work on it. So that's why it's not available yet.
Okay.
Yes, work in progress on Lineage notebooks.
Yeah.
Okay. Oh, we've got some chat going on. We had another comment. Can we make new terms a new term?
Absolutely. So the glossary, there's a really extensive glossary model. Let me take you to here when we talk about the common definitions. Let's see if I can find its semantics. So the internet's decided it's not going to talk. So no, that's not the right place. I went the wrong way. Let's go to the scenarios. One of the things we have is a lot of information, and yeah, here we are. So the glossary structure is very rich in Egeria, and there is an access service called the Subject Area Access Service, which provides all of the APIs for creating terms and categories and things like that. So I think trying to find the I have got some pages which I can't find at the moment, which show the structure of the glossary, which is but as I say, there are glossaries folder structures called categories as well as terms, and then these can be linked together in a very wide range of relationships.
Okay, we've got another question for you, also with a congratulations on the project, which is lovely. So how in Egeria do we link logical names and physical names of attributes? And actually maybe also how are we linking glossary and technical metadata? Okay,
so there's a special relationship that connects something technical with a glossary term. And I wish I actually could find the pages where those are defined, because actually that gives you a very nice picture of how they connect together.
And also the logical name and physical names of attributes.
Yes. So there are different areas of the model I was showing you. So there's the physical. This is what we've extracted from the environment. And then there's a design model area, there's a glossary area. And we can then create relationships between a model element that describes a particular logical attribute, and then link that down onto a specific column in a database, and also link the glossary term to either or both the logical model element or the physical term. So typically everything links to the glossary term, because the logical view is rarely one-to-one with the physical. So we link everything up to the glossary term, but you can actually link conceptual, logical, physical as well.
And is that all automatic, or is it manual, or?
It's so there's only so much we can do automatically in terms of extracting the structural type of the data, and that might be enough to identify candidate logical definitions. So for example, there may be two addresses in a particular employee record, you need additional knowledge to be able to distinguish between the work location address and the home address, although at the moment that's all the same. But typically there would be different values. So we can do some things, but at the end of the day, it typically takes the owner of the data to actually confirm the mappings to glossary terms or to logical models. The only time you can be sure it's correct is if you're doing a model-driven development type approach where you're taking the logical model and you're generating the physical model. Then you can be, you can be absolutely sure on the relationships. But most of the time we're reverse engineering an undocumented IT landscape.
Okay, I think we've gone through all the questions there, unless anyone wants to type another one. And Nigel's been answering some questions in the chat window as well. I've not stayed up to date with. I don't know if there are any last comments, Mandy and Chris, that you want to make today before we wrap up.
No, would you want to talk about the lightning talks for tomorrow?
Yes, that's what I was just about to do. So tomorrow, our last webinar meetup day. Oh, thank you, Mandy. You put it on the screen actually for me. I'd written it down as well. So tomorrow we thought we'd do a selection of shorter lightning talks to sort of go through some of the areas where Egeria is sort of making an impact and things that we're currently working on. So, you know, of course, lineage is a huge area that ING are working on and that we've all been focused on. Conformance suite, which is something we mentioned earlier, something that the team in IBM sort of spent a bit of time on this year, amongst other things. But tomorrow we thought we'll look at supporting ethical AI, which Mandy's going to cover. We're going to look at industry models and business glossaries. So we're going to take a perspective of looking at, you know, a whole glossary, what a glossary is, how they're used. And we'll talk a little bit also about the terms of the, you know, the importance of a glossary and that we can sort of import these into Egeria to sort of link back to the rest of your metadata. Then we'll talk about is a little slightly bit more IBM. Of course, Mandy mentioned we're integrating Egeria from our perspective at IBM into the cloud packs that we have as a framework for metadata. So we'll talk a little bit about a cloud pack, what that is, and integrating Egeria. And then one that I think is really exciting, and this is Egeria driving enterprise APIs. So it's not just all about the data lake. Our data definitions and our metadata can be used in so many other areas, you know, just driving our security access and rights, which is in our other webinar that we've got up on our YouTube site. But also one thing that we're going to be looking at in the future is driving enterprise APIs, and ING Bank will be talking about that, some of their ideas about what they're going to put in there, some of the stuff that they've already done with Egeria, but that's not available for release yet. It's things that they've been looking at over the past year. And again, a bit of a Q&A with the Egeria team. We'll probably have a fuller team on tomorrow to do Q&A with. So we're back again tomorrow at the same time for another 90 minutes of metadata. If you have got any more questions, you can sort of reach out to us on Twitter or on our Slack channel, or save your questions up for tomorrow. It'd be great to sort of see you all again. And thank you very much from me. I think we'll close the session on that. Okay, thank you. Goodbye.